My name is Zach Gellner.
And I'm Coleton Kotch.
And what you're looking at right now is our project in action. It's the culmination of tens, if not hundreds of hours of work and thousands of lines of code. My partner and I chose to make an environment and evolution simulator as our project. We chose this project because we felt that it would be challenging but still feasible to complete within 2 months. Our goal was to create a program that allowed the user to customize a variety of restraints and factors that affected the environment, and then the user could watch the outcome. Our simulation uses resources, animals, predators, and a genetics system to achieve this. Once the program finishes running, it spits out a series of plots like what you can see on the screen here. These plots give the user a variety of information about what occurred during the simulation, and by extrapolation what the user can do to change the result as well. The top left plot shows the presence of various genes in the animal population over time. The top right plot shows a similar thing but for the predators. The bottom left plot shows the populations of the two communities over time. And finally, the bottom right graph shows various statistics that might be of interest to the user over time.
Here's how the program works. It first creates an interface to allow the user to customize a set of initial conditions. Once the user hits the start button, it loads all of the conditions into a function file we call compute. This sets up the simulation by creating the environment class instance and visualizing all the information for each step. The compute file also handles the plotting of all the results at the end of the program, as well as handling the environment's resources as well. The environment class is what creates all of the animals and predators upon initialization. It's mainly responsible for making sure that all of the animals and predators move each step, checking for deaths in the animal and predator populations, and handling the reproduction process for both animals and predators. Some of the animal motion, including interactions with predators, is computed here. It has one primary function, being the iterate function, along with a set of subfunctions for streamlining some of the calculations. The animal and predator classes mainly serve to hold on to information unique to each individual animal and predator in the environment. Each one has a unique set of genes that are passed on to their offspring as well. Similarly to the environment, they have a primary function called step, and a bunch of sub-functions as well.
To pull off this project, we set some milestones for ourselves that would guide us through the different stages of the program. The first one was finalizing the structure of the code, then it was scalable animal motion, then we did the genetics system. After that, we handled hunger and resource management, and finally we had reproduction as our last milestone. Here's a look at one of our older project files. It shows us animal motion, but it can't handle scalable animal motion. It can only handle the one animal that's on the screen. As you can also see, it's running a lot slower, and this is because of the fact that we didn't optimize the code at the time. This is also before we adopted our newer code structure, which used an environment class to manage a lot of the functions involving the animals and the predators. Before that, the equivalent of the compute file was doing all the work, which was fine for the 1 or 2 milestones we had done at the time, but once we started moving into more complicated tasks, we realized that we had to restructure the program a bit. That was the biggest takeaway for both of us coming out of this project. The structure of the program makes a huge difference when it comes to both the organization of the code and the functionality of the code. Overall, I'd say that we're both quite happy with how the project turned out. We made something that was very unique in MATLAB, and we learned a lot from it as well. This is one of the most complicated programs that either of us have ever worked on, and because of that, we can't go in depth about how every mechanic works in this video. If you want to learn more about the project, we recommend that you download the code and give it a try for yourself. The whole premise of the project is built on experimentation and how changing little values can lead to some greater change in the outcome. A text file will be included with the code on how to operate the program. With that said, thank you for watching the video. We hope that you give our project a try.